All right. Hello, this is Mike Pennacchi with Network Protocol Specialists, and we are going to get going with our presentation. So this is my first YouTube live streaming event, so I'd like to welcome everyone. And there is a slight possibility that we could run into a technical difficulty here, but we are going to do our best to make sure that you get a good presentation today. So the presentation today is based on a presentation that I did at InteropITX in Las Vegas. And this is the Killer Network Toolset. And this is a set of tools that I've put together. Well, I haven't put them together. I found them out there. A lot of them are open source tools. And we're going to take a look at how we can use those for going out and troubleshooting our network problems. Now, there is a live chat that's going here. There's a slight delay between what I'm saying right now and what you're hearing. But what I would like to do is encourage you to go out and use that live chat to ask any questions as we go along. So in addition to the PowerPoint slides, we're going to be taking a look at some live views of what we can do with being able to go in and use these different tools. So with that said, let's go ahead and we're going to get our presentation started here. All right, so just a quick introduction of me. My name is Mike Pennacchi. I'm owner of a company here in Seattle, Washington called Network Protocol Specialists. I've been going out and troubleshooting networks for about the last 25 years. I started out as a network administrator. Some things were running slow on the old Banyan Vines network that I had. So I went in and started using a network general sniffer back then to do some packet captures and dig in and start taking a look at what was going on with packets. I became so enthralled with doing that I quit my job and I moved to California and started doing it for a living. I've been an instructor at Interop for the last 21 years. So if you haven't been to Interop, this is an example of the type of presentation that we do there. Hopefully it gives you an idea of the type of technical information that's covered there. You're going to notice I keep looking down. I've got that live chat up on the screen. Also, because I'm producing this myself, I'm going to be looking around at the different monitors just to make sure everything's working properly. Like I said, I started out as a LAN administrator, application developer. My email address is mike@nps-llc.com. So if you would like a copy of this presentation after we get done, feel free to send me an email, and I'll bring that up at the end as well, and I'll mention it as we go through. But don't hesitate to send me an email if you have any questions, or if you'd like a PDF copy of this presentation, I'd be happy to share it with you. My Twitter name is mpanac. I really don't use Twitter probably as much as I should. One of the big ones is the LinkedIn group that I have. We've got close to 10,000 members now. It's the Protocol Analysis and Troubleshooting group. So feel free to go out and join that group. Our goal is to talk about network troubleshooting. Okay, so when we take a look at these different tools in our presentation today, we are going to be taking a look at 3 different platforms. So the idea here is that I have tools that work really well on a laptop. I have tools that work really well on a centralized monitoring system. And I have tools that work really well on a remote troubleshooting platform. And in a few minutes, we'll talk about what that remote troubleshooting platform is. And in fact, I've got a picture of it that we'll bring up. Also, for some of the other things, I've got a camera set up here so I can show those to you live as we're going along. Okay, so let's move forward with the tools that we're going to look at for the laptop. Now, the tools we're going to take a look at for the laptop are Iperf, and we're going to look at this as the client end of Iperf. And we're going to find that Iperf is really good at doing throughput measurements. So we can use Iperf to measure what the throughput is between one device on the network to another device. And one of the things we hear all the time is the network is slow. So by using a tool like Iperf, we can go in and measure what the throughput capabilities are of the network. And once we know what those throughput capabilities are, we can determine, is this a network-related problem, or could this be a problem with an application? We're going to take a look at Wireshark, and we're going to look at how we can use Wireshark to go in and take a look at packets. I just got done installing a Grandstream IP PBX for a friend of mine, and I've been having some trouble getting the emails to go out properly. And what we find is that devices like that have built-in packet capture. So here I've got this device loaded up at a remote site. I can do a packet capture, bring it back down to my PC, and see exactly what's going across the wire at the time I'm having the problem. We're going to take a look at Wi-Fi Explorer. Now, Wi-Fi Explorer is a tool I run on the Mac, and it goes out and takes a look at what's happening in our wireless networks. Take a look at TCP traceroute and Nmap. Now, we have a limited amount of time here, so my goal is to introduce you to these products. Now, the other thing is, I went back and I took a look at some of the comments that I got back from the presentation I did in Las Vegas, and somebody said, well, this is great, but I'm in a large company. Here's the thing I found. There are tools that we may put into a large organization that are going to allow us to go in, do packet capture, do monitoring, be able to get a good picture of what's going on a very broad sense at very high rates. What we find is that these tools are tools that work really well for going in and troubleshooting a variety of different problems. So we're going to run Iperf to Uta's office that works with me, and so we can measure what that WAN latency is. So is this the total package that we would use for troubleshooting a large organization? Absolutely not. Are these a few tools that I've run across in my experience that do a really good job of helping us troubleshoot problems? Absolutely. Okay, so let's move on and take a look at some of these other tools. So on Centralized, these are going to be the tools that I want to have in place running over a long period of time. So for this, we're going to take a look at Cacti. So Cacti is an SNMP reporting tool. So Cacti is going to allow us to go in and monitor SNMP devices over an extended period of time. This is going to be our routers, our switches. We're going to see how we can use this at looking at our utilization. So if we use some of our tools like Iperf or Smoke Ping, and these show that we see higher than normal latency or we see higher than normal packet loss, I want to know, is this a problem due to utilization? So this is where a tool like Cacti is going to come in and help me out. I've also got OpenNMS. Now, OpenNMS is a red light, green light tool. So what that's going to allow me to do is monitor device availability. We're going to look at how we can use this to generate reports that show us what our availability is over a period of time. So for my routers, I can go in and take a look at what my availability was over the month of June. So if someone came back and said the network is down all the time, well, I want to be able to show that either the network is down all the time or it's not. Okay? And we're going to finish this up with Elasticsearch. Now, Elasticsearch was one of those tools that I had been looking for some time. And I was talking to my buddy Ray down in Houston, and Ray said, Mike, you got to check out Elasticsearch, man. This is going to allow us to take information from our different devices, and for the most part, we're going to use syslog. We're going to take a look at a little bit of what we can do with packet beat and what we can do with NetFlow, but primarily, we're going to look at how we can use Elasticsearch to suck up all of our syslog information and allow us to generate reports based on that information. The great thing there is I've got all of these devices on my network that are spewing out all kinds of pieces of valuable information. By being able to go in and collect that information and then report on it, starts giving me a good picture of what's going on. Okay? And then lastly, our remote troubleshooting platform. So in most organizations, we're going to have a central office somewhere. This could be a big data center, could be a small one, just another one of the offices. Then we're going to have satellite offices out there. Our remote troubleshooting platform is the platform that we can deploy out to these remote sites. By deploying this platform out to the remote site, I can now get an idea of what's going on at that site. Because in many cases, I may have an MPLS connection back to my main office. I may have a VPN connection. So this is going to mean that I am going to have traffic originating from that remote site and going directly out to the internet. And if I'm back at the data center, I'm not going to have any view into that information. So by deploying some of these tools out there to that remote site, we can start getting an idea of what's going on. So some of the tools we're going to take a look at for that, Wireshark, TCP traceroute, Nmap, packet beat, and also we're going to take some of those other tools like smoke ping, and we could do Cacti and deploy those out there as well. So here's this little platform that I put together. And what we see is that I took a bare bones PC, I loaded Linux up on it, and this PC has 2 NICs. So let me get my hand straight here. We kind of lose that. But what we see right over here is that that PC has a couple NICs on it. And one of those NICs is connected to a fault-tolerant inline tap. So the idea with this fault-tolerant inline tap is that the tap up there in the upper picture is placed in line with my internet connection. This tap, if it loses power, will continue to pass packets. So the idea here is that if I lose power or something happens to that tap, it doesn't take down that remote connection out, or that connection out that remote site. We then take that data and we aggregate it and we bring it into this old platform so we can start analyzing that data. Now in this case, what are we doing? We're capturing that data and writing it to disk. Now is this going to work for a 10 gig connection? No. But if we put this out at a remote site, where let's say that we have a 50 meg connection, 10 meg connection, this thing's going to capture all day long. So in this case, I put in a 480 gig mSATA drive. So it's just writing that out there. We'll look at how we can get out there to that information. Okay? So just going out and taking a look and see how our presentation's going there. So when we come in, we take a look at that, we can see that we can plug in, we're monitoring on one of the ports of that device. On the other port, we're using that to communicate with the device. Okay? So, getting in the path of the packets. If we're going to capture packets, we have to get in the path. Now, we could use a fault-tolerant tap like the one I showed you. Now, the key with the fault-tolerant tap is that this will ensure that our network doesn't go down if we have a problem. If that isn't a big concern, if I just need to be able to get in line to be able to do a quick test, one of the things I can use is I can use a span port. Now in most cases, span ports are available on my server, so it makes it really easy to be able to go in, connect up to the server or to the switch and monitor the servers. Okay. Now let me show you one that I put together, and that's our Netgear GS105E. This is about 35 bucks on Amazon, and what I can do is I can take and span port 1 to port 4, and this supports about 500 megabits per second full duplex. So I'll tell you what, let's do this. Let's switch over here. I'm going to switch my camera over, and what we see is here we've got one of these little Netgear GS105Es that I've put together. So I've gone in and I've marked which port is the source. I've marked which port is the analyzer. So what I can do is I come in here and I'll plug my PC right here into port 1. I'll plug my PC running my analysis software right here into port 4. Then I may plug port 5 into my network. So what's going to happen is any traffic that comes into this port right here is going to be mirrored over to this port right here. Now I told you before that this is limited to about 500 megabits per second. And that's not a bad thing because this is a gigabit switch. And if I supported full line rate gig, what I would find is that this source port could overrun this analyzer port. But because it limits my throughput, I'm never going to be able to exceed the output speed of that port. So what I find is I've got a whole pile of these things. I carry these in just about every one of my bags. So when I'm going out and I'm doing troubleshooting, I carry this along with me. and I can put this in line with a PC, I can put it in line with another device on the network, and it gives me a way I can go in and see what's happening out there. Okay? So by being able to use that, I can get in the path of the packets. And again, it is, we find it's just a really cheap little tool that I can use to get in the path of those packets and start doing some troubleshooting. So handy little gizmo, use that all the time. All right, so with that said, let's talk about Iperf. Now I'm just going to take a look over here. So what I would say is, I see there's people joined on. Feel free to send in any chat messages if you like. I am a question-driven person. So as I'm presenting, one of the things I want to make sure is that I'm getting you information that you care about. So by you sending messages to me and letting me know, do you have a question about something? I know, one of the things I've found when I go out and do classes is people are hesitant to go in and ask questions because they're afraid everyone else knows the answer. Well, the fact is, not everyone else knows the answer. So it's not a bad thing to ask a question. I can make sure I get that answered for you. All right, so let's talk about Iperf. So Iperf allows us to measure a variety of things. We can measure throughput, we can measure packet loss, we can measure jitter. Now, packet loss and jitter really come into play when we're looking at deploying things like voice over IP. So when I'm doing VoIP, I want to make sure that I have the bandwidth I need, and I want to make sure I'm not losing packets, and if I'm sending those packets with a very specific interframe arrival time, that they are arriving at those times. So this is where I can use the UDP option of Iperf. But we're going to start with looking at TCP and how we can use this to measure throughput on our network. So I'll move over here just a little bit. So it helps us answer questions about bandwidth availability. So we can see what that looks like out there. All right. So in this case, what I'm going to do, and let me switch over. I'm going to take myself out of the picture for just a second. So in this case, what we find is I am doing a throughput test. And I am going to take and I'm going to use this server over here, 10.0.0.53, and I'm going to send the traffic from 10.0.0.101. Okay? So let's take a look at that in a real life example. Okay? So in this case, we're going to, we're going to switch over here and we're going to drag in a window right here, and I'm going to hit Control C on this. Okay, so this is a machine that I've got set up for doing network monitoring, and this is in my office. It's running Ubuntu. Okay, in fact, we can get rid of that back there. All right, so now if I come in and I were to say I want to open up another terminal window, and this one I'm going to log into a Raspberry Pi located at Uta's office. Now this Raspberry Pi, let's just give this a try right here. That Raspberry Pi is set up so that I can run a variety of tools on there. So I went ahead and I installed Iperf. So what I'm going to do is on that Raspberry Pi, I'm going to say Iperf -s. Now when I do an Iperf -s, what this does is it starts listening on port 5001. So it shows us right here, it's listening on port 5001, and it's waiting for a connection. So I'm going to come back, and I'm going to say Iperf -c 10.0.12.10. So now what I've done is on the Pi, on the other end of the WAN connection, I've started a connection that's listening. On my connection here, I've started a throughput test, and I'm sending data from the server here in my office across the VPN tunnel to Uta's office. And we got 8.74 megabits per second. So what that does is it gives me an idea of what that throughput capability is from my office to her office. Now I could do Iperf minus C, 10, well, I'll just hit up arrow. I'll say minus D. And what this is going to do is this is going to do a dual test. Now with the dual test, it is going to run traffic in both directions. Okay, so it tells me I got 9.6 megabits in one direction and 4.2 in the other. Okay. So one of the questions that came in, because I'm going to try and answer these questions as we go along, is what is that little computer uses with the two onboard NICs? Well, the computer I'm using with the two onboard NICs I got it off of Amazon, and it was just a bare bones, fanless piece, dual NIC PC. And what we find is that a lot of times these PCs are used for running homemade firewalls. So if I want to download some free firewall software, I found that there's a number of PCs out there. I had a little challenge with getting some of those machines on Amazon, and if you want, and I'll put my email out there. If you want, I can send you some information. I found another company that in the Bay Area that has those machines, and they can get you as many of those machines as you want and give you a bid on that if you want. Okay. So one of the questions is, what version of Iperf am I using? You know, I'm going to have to go in, Ben, and take a look and see. In this case, I did, on the Linux boxes, I did a sudo. Let's see if we can do a Iperf minus V. Oh, right there. So on my Linux boxes, I'm running 2.0.5 version of that from 2010. So that's, if you do a sudo apt-get install Iperf, that is the version that gets downloaded and comes in. So, you know, that little dual NIC PC, that was one, you can actually get them with up to 4 NICs, and we find that we can capture on all those interfaces at the same time. So, pretty handy little feature there. All right, so in this case, what I've done is I've just done an Iperf test from my office to Uta's office. Now, if we do an Iperf minus H, this gives us all of these different parameters that we can have in here. And it shows us, you know, what we can do. Now, an example of one of those is bandwidth. So let's do this. We're going to hit Control C here at Uta's office, and I'm going to say Iperf minus S minus U. Yep. All right, now, instead of being in TCP mode, I'm in UDP mode. So I'm going to come back here, and I'm going to say Iperf minus S, or minus C, minus U, 10.0.12.10, minus B, and I'm going to say 64K. And every once in a while, we get these parameters. Let's do this. There we go. So now in this case, what I'm doing is I am doing a throughput test. I'm sending the traffic at 64 kilobits per second. And let's see. In this case, this came back. I'm pretty sure I didn't get 3.3 gigabits per second, but I'm going to take a look at this side. So this is the far end. What this does is this tells me that I sent my traffic across. I transferred 77.5 kilobytes worth of data. That data was sent at 64 kilobits per second. My jitter. Now my jitter is my variation in interframe arrival time. So that variation in interframe arrival time says that if I send frames every 20 milliseconds, that we saw some variation, that some of them were delayed, and that caused that gap to change. That change in gap will affect our voice over IP quality. So for your voice over IP phone system, there's a definition of how much jitter it can take. So what this does is it allows us to see what that is. We can also see that we lost 2 out of our 56 frames. This tells us we lost 3.6%, which is quite a bit. So in that case, I'd want to go in and find out what's going on with that path. So we can use Iperf to measure throughput. We can use Iperf to measure what our jitter and our packet loss are going across our link. Now let's see, let's come in here and I'm going to grab one of my machines. Now here's my probe PC. So I'm going to bring that up and I'm going to say Iperf -s. And we'll come over here. I'll say Iperf -c 10.0.0.205. So we're going to run this across our local area network. Actually, this is going from a VM to one of those probe PCs. So we'll see what kind of throughput we get. So here we got 206 megabits per second. Now, sometimes this can be a limitation of the CPU. It can be a limitation of what our concurrent streams, our bandwidth delay product. So I can put a -p, I could say 5. What this will do is this will do 5 streams all at the same time. So it gives us a way we can go in and do some testing, find out what that link is capable of. We find out right here, we're getting about 199 megabits per second, and that is all we're going to get out of that connection. Okay. So when it comes to taking a look at what we can do as far as our throughput goes and so on, Iperf is one of those tools that's going to help us go in and do that. Now, just as a quick note here, our flow of data goes from the client to the server. So when I just do an Iperf -s, that data is moving from the client to the server. If I throw the -d in there, it does a bidirectional test. All right, well, I better keep moving on here because otherwise I am going to run out of time. Here's an example where we did it on 100 megabits per second. And we can see that down here we got 94.5 megabits per second. Expected results. On a 100 meg connection, I expect to get 94.5. 94.9 is my theoretical maximum. So I expect to get in the mid-90s. Okay? Throughput, good throughput in one direction, poor throughput in another, could indicate a duplex mismatch out there on a connection. So that's something that we would want to be watchful of. Okay. Useful parameters, -t, we can change time. So we can say that I want to run this for a longer period of time. -p, change port number, etc. Now, let me do this. So I'm going to switch over here, wrong screen, switch over here, and I am going to go out here into my network monitor machine, and I'm going to say Iperf -s. So I'm going to run that as a listener. Okay, and then we're going to switch over to this camera. And let me just do this. There we go. All right, so I got my camera set up. I'm going to turn on my phone here. And there is, on my Android, I have got a Iperf client. So in this case, this allows me to run Iperf on my Android phone. So in this example, we can see I've got the -c 10.0.0.108. So if I hit on right here, it establishes that connection with the server. It says I'm connected with 10.0.0.108, and I'm doing my throughput test, and I got 42 megabits per second. So this actually allows me to use my phone as a way to do that throughput testing. So I went out to the Play Store in this example, downloaded Iperf, and away we go. So kind of neat way that we could walk around with the phone and use this as a way to measure our wireless throughput for this device. And one of the things that we need to remember when we're doing things, let's see, let's move this over. One of the things we need to remember when we're doing things like measuring throughput, especially with a wireless device like this, is it depends on how many antennas we have on that device. If we're using 802.11 AC, the number of concurrent streams that we have are going to impact what our throughput is. Okay? So when do I use UDP instead of TCP? When I'm doing things like checking VoIP. Okay? Here's some different parameters. Move my head out of the way there. So in this case, we say, are you going to be a client? What IP address are you talking to? Are we going to run in UDP mode? And what's our data rate that we're sending right there? Okay. And there's some of our results from UDP. All right. So let's keep rolling on. Wireshark. All right. So let's take a look at what we can do with Wireshark. And there's a few key things that I want to point out here. The nice thing about Wireshark, this allows us to go in and capture and decode packets. It's the tool that everybody wants to know how to use, but very few people put the time into using it properly. Now, I don't know if anyone that's on this webcast today joined in on SharkFest, but there was an opportunity to get together with a bunch of people doing Wireshark. I use this day in and day out. And like I say on this slide, we could spend the next 4 days talking about Wireshark. But there are a few key things that I would like to talk about in there. And let me just switch over to this screen while I get a couple of things set up. This is not my office, by the way. This is a computer room at the Living Computer Museum here in Seattle. And if you are in the Seattle area and you haven't had a chance to go to the Living Computer Museum, then I would highly, highly recommend it. It's a pretty cool place. I just got done doing a presentation there. Let's see. Let me just get out here and see if I can get to the file that I want to get to. There we go. All right. So, let me bring up Wireshark here. All right. So here we have Wireshark. And we've got some packets that are going across the wire. We've got, it's showing us that we've got a number of things going on. One of the things that we run into oftentimes with using Wireshark is that it's very easy to get confused on what it is we're looking for. What is that information that's contained in here that's most important to us? So one of the things I found, I was at Interop a number of years ago, and I typically did the Wireshark class. I noticed that Laura Chappell was doing the Wireshark class, and so she got up and said, well, Mike normally does this, but he couldn't be here. I'm in the front row. I'm here. But one of the things that she brought up was this bad TCP filter. And so I want to make sure I give her credit for that, because I most definitely grabbed this one from her. But in this case, if I come up here to the top and I type in TCP dot analysis dot flags. What this does is when I hit tcp.analysis.flags, this shows me every frame that has a TCP issue. So if I'm looking at a trace file and I'm concerned that I'm seeing packet loss, I can go in and by typing in tcp.analysis.flags right in here, this allows me to go in and see, what I've got, what's happening there. Now let me just try something here, and let's see if I've got this in my analysis tools. We're going to bring up Zoom It. All right, now Zoom It tends to work pretty well when we're looking at some of these things here. So let's try Control 1. Haha, there we go. All right, so there, make it a little bit easier for us to see on our screen, but there are our tcp.analysis flags. Now, when we type this in, if there's any frames that have TCP issues, and this is going to be retransmissions, this is going to be other problems, this filter will help us see those. Now, in this case, we see that it comes back and it says, well, we have a TCP window update. Huh. Well, okay, that's fine. I mean, a TCP window update's okay. So if I came in, and we'll hit escape, and I'm going to say, and not tcp.analysis.window update. And we're going to reload that. Now in this case, we got 0 frames. Now a lot of times when I'm doing a filter, not getting any frames could be an issue. In this case, what that does is that tells me that there were no bad frames in this trace. So if I'm thinking packet loss is an issue, if I do a capture and I go in and do something like tcp.analysis.flags and not TCP window update, that tells me very quickly that there are not any bad frames. Now, here are a few other things that are very important when it comes to using Wireshark to make this a very powerful tool for helping you get your problems solved quickly. One of those is that if you click on this little plus right up here, this allows me to go in, and we'll zoom in on that. This allows me to go in and put a label on this filter. And then I can come over here and I can say, well, there's the filter. When I do this, so we'll zoom out and I'll say Mike's filter. And I click OK. What that does is it saves that as a filter on here. Now, oh, that's funny. I don't see it. Let's go back in. Let's say bad TCP. And I'm going to say add a filter. I'm going to say, we'll just say Mike. We'll say, okay, there we go. We got that. There's Mike's filter. Okay, so I just didn't have enough room on my screen. But now, if I click on Mike's filter, it brings up that filter that we saw before. So the key is by clicking on that little plus, I can go in and save filters that are really useful to me. So that's pretty handy. Now the other thing that I want to tell you with Wireshark, and like I said, we could spend a lot of time talking about Wireshark. It's not really what I want to focus the presentation here. If this is something that you think is interesting, hey, let me know in the comments or something, or send me an email. And now that we've established that we can do a YouTube live event without it being a total technical disaster, maybe we'll do another one in the future on Wireshark. But what I will show you with Wireshark is that if I came in here and down at the bottom, let's go down here. Trick is getting to the bottom of the screen without bringing that up. Right here, we see it says profile TCP. So down there in the bottom corner, and actually you can't see because I'm in the way, so I'll stand right here. I'll go like this. Let's see, right there, profile TCP. So where it says profile TCP, that's the profile we're using. And what the cool thing is with the profile is when I use profiles, let's see if I can get out of here. When I use profiles, I can save all of these filters in a profile. So as an example, and let's get me out of the picture here, make it a little easier to see. If we get me out of the picture and I come down here and click on Profile TCP, what this does is this brings up different profiles that I've created. So I can create a profile for HTTP, I can create a profile for TCP, I can create a profile for SQL. It allows me to go in and create profiles that are specific to the type of troubleshooting that I'm doing. So by doing that, we can focus in on those columns that we're interested in. We can focus in on the filters that we care about for that protocol. But those are the two things. Those are two of my pieces of advice when it comes to taking a look at what's happening with Wireshark, is going in and taking a look at those take a look at those profiles, use your pre-canned filters out there. That's going to be really handy. Now, let me show you the one other one here. We're going to take that filter off of there. What I'm going to do is I'm going to come down in here and I'm going to find out where am I sending some data. Now this is where I did an Iperf across a wide area network link. And we see that we're sending data. The source is 10.0.0.111. That data is going to 10.0.0.128. And we see that it's a 1514 byte packet. Now what I'm going to do is I'm going to click on a packet that is one of my data packets out there. Now after clicking on that data packet, I am going to come up to statistics and I'm going to go to TCP stream graphs and I'm going to go to my Stevens graph. Now what the Stevens graph does is this graphs out TCP sequence number over time. Now by graphing out TCP sequence number over time, this allows me to see, how does that connection look? Now in this case, we can see that right in here, we had TCP slow start kick in, and then as we're going along, we're sending that data, and see how nice and straight that line is? When I see a nice straight line like that, that tells me that I'm sending that data across and I'm not seeing any packet loss. In fact, if I start hitting the plus symbol and I drill in, I can see right here that I send some data, I wait for ACKs. Send data, wait for ACK. Send data, wait for ACK. That is beautiful. That is exactly what I would expect to see when I'm sending data across like that. Okay? So we're going to close that. Now we're going to come in, and what I'm going to do next is I want to go in and I'm going to open up a trace file here, and I'm just going to switch over to me because I am a little cautious about what all pops up on the screen, or at least I try to be. Now, what I've done is I've swapped over and I switched over to a trace that contains some packet loss. So in this trace, as I come down, I'm going to come in here and I'm going to click on one of those frames that has bytes in it. And I go back and I'm going to go to statistics. I go to my Stevens graph. Now we see that with our Stevens graph right there, that that doesn't look so good. And this is a case where our data is getting lost. We're seeing packet loss. And what happens with that? Well, when we see the packet loss, we get retransmissions. In fact, I'm going to go right in here. I'm going to start hitting the plus sign. And we're going to move over. we're going to drill into this. Now, what I want you to notice is right in here, and let's zoom into that. Okay, so right here, this is what I'm mostly interested in. And what we see is that there was a dot right here. And then we see that another dot right there and another dot right there. That is the same frame being retransmitted across that link. So this indicates that we are seeing TCP retransmissions in here. This is packet loss occurring. This is bad. We don't want that. So this is an indication of what packet loss does to us. So our packet loss, we zoom out, we see that when we see that packet loss, we now go into TCP slow start. So we have to start picking back up again, and then we take off, and then we're going to get going, and then we're going to see more packet loss. So not a good deal. We don't like to see that. Bad, bad, bad news. Okay? So let's see. So those are some of the things that we find about Wireshark, right? Now, like I said, you can find some videos out there. I've got a few videos I've done. Happy to do more. But Wireshark is one of those tools that lets us get in and see exactly what's going on with the packets. Okay. Wi-Fi Explorer. So Wi-Fi Explorer is a pretty neat little tool. I was talking to a friend of mine, Keith Parsons, and I said, Keith, I just got this Mac. What's a good tool for going out and taking a look at wireless with the Mac? Yeah, he said, check out Wi-Fi Explorer. So it requires OS X 10.7 or higher. It's about 20 bucks. So not too bad when it comes to network troubleshooting tools. It's a really powerful Wi-Fi discovery tool, and it allows us to export the discovery data to a CSV file. So here's a case. When I was at Interop, I was staying at the MGM Grand, and I fired up Wi-Fi Explorer. And I noticed out here that I saw this Netgear 46. Now this is an example of a device that's running in a 2.4 frequency range that is using a 40 megahertz wide channel. Now that is not good, because not only am I stepping on the people where my center frequency is, but I'm also coming in and using up this big space in here, and I'm affecting all of the devices that are talking in that same range. So I happened to be on the phone with my wife, and I said, somebody's running a 40 megahertz wide channel. And she said, well, that's not good. So she said, what's the network? I said, Netgear 46. And she said, that's you. So what do you mean that's me? Well, I carry this little Netgear travel router around. And what I found was that I would never, ever, ever set it to 40 megahertz wide channels. But how did I end up in this situation? Well, in this case, I move my head a little bit, we see that right here where it says 300 megabits per second. So it turns out that on this old Netgear travel router, that if you say, I want to get 300 megabits per second, because who wouldn't, it will automatically put this in 40 megahertz wide channels. Doesn't tell you anywhere that this could cause all kinds of problems. But Wi-Fi Explorer, pretty handy little tool. In fact, let's see if we can bring this up right here. Let's see, better yet. We're going to select that, and I'll select Wi-Fi Explorer. We'll start that up, and we'll make some room here. Oof, not that. We want that. Here's Wi-Fi Explorer right now. So this is on my little network. Okay. So this is running on here. It's showing that we've got the office network, we've got PR Guest, PR Home, Netgear 77. So this shows what networks we can see out here in my studio. And this starts telling us, how wide a channel are they running, what channel are they on. So we can see immediately that we've got this nice division right here, that we've got a gap between the devices on channel 1s, the ones on channel 1, channel 6, channel 11. We can see that we only have one access point on channel 1 right here. So if I was going to go out and select what channel I might want to use for another AP, well, 1 might not be a bad one. And it shows me what's happening at 5 gigahertz. So as far as a tool that allows me to go out and find out, what's out there, what's the max bandwidth, what's going on as far as sending data across, this starts giving me a picture of what's going on with my wireless. So I found Wi-Fi Explorer, very economical tool for getting a good picture of what's going on with your wireless network. Okay, so we're going to go ahead and close that. And it's going to ask me, do I want to save that discovery information? I'm going to say no, but I could go in and save that information if I wanted to. TCP traceroute. And this is a case where we're following the path of a TCP frame through the network. So I'm going to come over and I just want to make sure I've got something set up here. Let's see. We'll do that. All right. So what does TCP traceroute do for us? Well, TCP traceroute allows us to do a path analysis. We can take a look at what our layer 3 path is for the path of a TCP frame, and it allows us to specify the port number for that TCP frame. So if I do a traceroute, this will give me an idea of what the path of a packet is that's either an ICMP or a UDP frame. So depending on the implementation of traceroute, they are using either UDP or ICMP and incrementing the time to live. So if I send out a frame with a time to live of 1, it gets to the first router, that first router decrements that time to live to 0, throws it away, sends a message back to me. Time to live expired in transit. By going in and taking a look at that, I can see which router killed that packet, and this is how I do my path analysis. Now, with TCP traceroute, what that does is that goes in and it uses TCP SYN frames to do the same thing. So in this case, if I wanted to trace a path to my email server using port 993, so let's come in here, and I'm going to just come out. I've set this up on my, well, we'll do it from one of my Linux boxes here. So I'll hit Control-C, and I'm going to say TCP traceroute secure.email srvr.com 993. We're going to say sudo. We're going to run that. So what this is doing is a path analysis using TCP SYNs. So it's taking a look at what path do we take to get there, and we find that we made it all the way to our email server. We got a SYN acknowledgement back. So this tells me for port 993, what path do I take through the network? Well, let's go back now, and we're going to change that. We're going to do port 25, because port 25 is a pretty important email port there. So I'm going to hit that, and it is doing that path analysis, and we see that it stops at our MikroTik router. Why does it stop at the MikroTik? Well, it stops at the MikroTik because there's a rule on the MikroTik that says stop, that block port 25. So if somebody has gone in and set up a firewall rule that's causing us to drop packets, causing that to get blocked, then this is going to show us where that is. So I'm going to come back over to that firewall and I'm going to disable that rule. Now we're going to come back and we're going to rerun that traceroute. We see that it gets through. So TCP traceroute is a great way that if we are running into a situation where packets aren't getting through, some packets are, some aren't, ping is not going to help us figure that out. Regular old traceroute is not going to help us figure that out. Instead, we need to use a tool like TCP traceroute to allow us to go in and trace the path of those TCP frames. So this allows us to validate that either our firewall rules are doing exactly what we expect them to do, or they're not, and they're throwing away packets that shouldn't be thrown away. Okay. So that helps us do some of those things. All right, so in this case we can see that we reached the server in 16 hops and port 993 got all the way through. So if 993 was one I had to have for my email to work properly, that's going to tell me things are working. So in this case, port 25 blocked at local router. So this is the one we just recreated. So in this example, I tested port 25. I found out it was blocked there. So by doing this test, it's a way that I can find out where along the path am I running into my problems. All right. So Nmap. Nmap is one of those tools that a lot of times we might use this tool for going out and doing penetration testing or finding out what ports are open so that we can use it for security. Well, not only can we use it for that, but we can use it for network discovery as well. Okay. So it's a free and open source tool. We can install it. First came out in 1998. It can be run from the command line, or we can use the Nmap GUI right there. So if we want to use the GUI, we can use that. So I'm going to take a look and show you what some of the more useful Nmap commands are out here. Scanning a single host. So I can come in and do Nmap and scan my default router. So if I came in and I said Nmap 10.0.0.1. So this is going to unleash Nmap on my router there, and it's going to show me what ports are open. So in this case, I can see I've got FTP, SSH, Telnet, domain. These are all ports that are open on the inside. Now, if I turn around and I did this same test from the outside, it could start giving me an idea of, do I have any ports that are open that maybe shouldn't be open? Okay, so that's one use of Nmap there. So that's going through and taking a look at a single host. I can do Nmap 10.0.0.0/24. I could scan my whole subnet. We are not going to do that because we just don't have the time to do that today. It takes a while because it's going to go through each host and scan those, but this gives me a way to scan a whole subnet. Let's say that there is a specific list of hosts that I want to scan. Well, I could create a list of hosts in a text editor and then go in and provide it with that list of hosts, and it will only scan that list of hosts. I could do a ping scan. I don't want to scan every single port. I just want to find out what's going to reply to a ping. Well, I can use the -S_P. I could scan for a specific port. So if I say, hey, I want to find out what web servers are on my network. All useful things. And we saw recently with some of the different viruses that have come out that they attacked SMB. So I could do a scan for port 445. I could do a scan for port 139. These would be ways I could go out and quickly scan my network and find out where I have file shares on that network. DNS scan. This is kind of an interesting one because when I run this one, it will go out and do DNS pointer record lookups on each one of these addresses. So in this case, I could go out and find out what IP addresses have pointer records associated with them. So what's really interesting is if I go out and I do a scan and I say I'm going to take a range of IP addresses that I know a company has on their outside connection, I always find it's interesting when we come back and we see things like firewall. I just noticed, on Facebook, there was a mention of, you need to load different router software because your router software might be hacked. And then each response to this post was people going in and detailing how they've set up the security on their networks. And it's got their name associated with it. So I just think it's interesting that if you're going to go to that trouble of setting up high security on your home or office network, I wouldn't go out and detail all of that security in a post on Facebook. So this just gives us an idea of what devices are out there and what their names are, what might have names associated with it, what might not. This is what I really like. This is the ARP scan. So in this case, what I've done is I've gone in and done a scan of the network, and I'm ARPing for all the devices on that network. So this is minus s little n. So let's go over here, and we're going to do that scan on our network. So I'm going to say Nmap minus sn 10.0.0.0/24. So this is going to go through an ARP for all the different devices out there, and it's going to show us what devices replied. Now, we're going to do something a little bit different. Now, in this case, here's the difference. The first time I just ran Nmap, and I didn't go in and put sudo in front of it. Now, I got back the IP address, and it told me the device was up. Now we see that when I put sudo in front of it, I get a little different response, and that is, it comes back and it gives me the MAC address that goes with that device. So now, not only do I get the pointer record name, but I get a MAC address to go with it that tells me what type of device that is. So what I really like about this ARP scan is that it's going to go out, it's going to scan the network, and it's going to tell me who's connected to my network at this moment in time. We can do operating system detection, so we can find out what type of OSs are out there. Okay, so now here's where we start putting these tools together. I've got Nmap that goes out and scans the network and finds out who's out there, what their MAC address is, what their IP, and their name. I can put that out as an XML file. So in this case, I say Nmap minus output. I'm going to do XML. I'm going to call it 10.0.0.xml. I'm going to do my ARP scan. So it's going to take it and it's going to put it out in a file that's going to be 10.0.0.xml, and that's going to be my ARP scan results. Now, if I can convert that XML to HTML using I always get this one wrong. This is a tongue twister. XSLTproc. So if I do sudo apt-get install XSLTproc, what this will do is I can say take and convert that XML to HTML. And what I get is this scan report right here. This scan report shows me who's attached to my network in HTML. So here is what we can do that's really cool. So let's see. Let's see if I can get this back up here again. SSH. We'll bring this up. Okay, we're going to get to a few of these. But if I come out here and I go to 10.0.0.205, this is that network analysis probe. So when I told you that I built this little, we built this box that sits out there on a remote network. This box has a number of tools running on it. It's got smoke ping. It's got my capture files. It's got my ARP scan. If I click on the ARP scan, what we see is this ARP scan last ran today at 11 a.m., which was just a few minutes ago. and it scanned these devices. So what it's going to do is it comes out and says, hey, 10.0.0.1 is my MikroTik. 10.0.0.2 is my storeroom switch. 0.5 is my desktop switch. This is running every 15 minutes. So there's a cron job. Goes out, runs every 15 minutes, and it does an ARP scan of the network. This allows me to find out in the last 15 minutes who was connected to my network. So how many times have you had a situation where you've got a remote network out there and you want to be able to go in and find out who's on that network, what's their MAC address, what's their IP? Using the ARP scan, putting that into XML, taking that XML and converting it to HTML, we can now display it as a web page. So like I said, you can shoot me an email, send me a message, and I will be more than happy to send you a copy of this presentation. In fact, let me come over here. I'll just put in the comments. If you didn't get it earlier on, there's my email address. I'll send you a PDF of this. And there you can see that there's the commands in there for taking and converting that to an XML. Okay? So, next, Cacti. Cacti allows us to graph out SNMP values. So I can take things that are SNMP. I've set this up for UPSs. I've set this up for environmental monitors, for monitoring things like monitoring temperature, things like that. We're going to look at this for monitoring utilization. So Cacti allows us to graph out SNMP values over time. Great for UPS, great for utilization, great for any SNMP managed device. How do I set it up? Well, I can go in and type in sudo apt-get install Cacti. So then I can log into Cacti. Now, when I go in to set up a device, what I would do is I would come into devices and I would come up here and click add. And when I go in and click add, this allows me to type in the IP address of the device, put in the SNMP community string, all that important information. Okay. So now I can start seeing my graphs. So let's go over here and I'm going to come into Cacti. So here's where I've got some graphs of my router. Now, in this case, this is a link I have going up to a switch in the attic. Now, this switch, we see that there's pretty constant utilization across there. In fact, if I click on that, this shows me my utilization, my weekly utilization. So I can see my daily. I can come in here and I can see my weekly. And this gives me an idea of what that looks like. And I see it's pretty continuous. Why? Because I've got a IP camera that is being monitored by a little program called ZoneMinder, and it's always moving data across there. But I may see that right here I saw a spike in utilization. So in that case, I could come in and click on this. I could zoom into that time frame, and I could see that during this time period right here, that my outbound utilization hit a maximum of 45 megabits per second. I've got a 50 megabit per second connection here. So something upstairs was using up a lot of my bandwidth. Okay. So if we came back to our main screen, right here, here is my Ethernet 1 gateway. This is my connection going out to the internet. And if we were to highlight this, right there, what this does is this shows me what my utilization looks like on my internet connection right now. Now, what I find is at 10 a.m. this morning is when I started this webcast. Well, what do you know? Right here, we see that we're running at about 2.5 megabits per second. And that's what I have my codec set to for this presentation, is 2.5 megabits per second. So this is we can see that this is how much of my bandwidth is being used. So if we saw some problems with the presentation, if we saw problems with quality, with audio, we could go back and see, did we see other utilization on this link at the same time? So if I go into my graphs, I could say, well, let's take a look at Uta's office. What does the utilization look like at her office? Well, in this case, if I zoom in, I could see that, we've got something running across here that started at about 7:30 last night that we see a bunch of inbound utilization. So that's interesting. Now it's not very much, it's only about 12K, but something is talking to something on her network. So by going in and taking a look at our different graphs, here's one I set up for interop. This is just my router right here. I could take a look at my downstairs access point. So I could see what does the utilization look like on my access points, and what does my guest network utilization look like. So this allows us to go in and take devices that support SNMP. Now in this case, I've got some MikroTik HAP access points. They support SNMP, so I can go in and pull out the utilization information on my different wireless networks, etc. So Cacti, great tool for monitoring utilization, because if we find that our utilization jumps up, this could be an indication that there's a problem. Here's the environmental monitor where I'm monitoring temperature. You can see it warms up during the day, cools down at night. All right, let's just take a look at what we got going on here. Make sure everything looks good. All right, smoke ping. So smoke ping gives us latency and packet loss over time. So this allows us to monitor what our latency is, our packet loss, and our long-term changes in latency. And we configure this via a text file. So after you install smoke ping, we will go into the configuration screen, or the configuration directories. We will set up targets. What will happen is every 5 minutes, we will send 20 ping packets to that device. It will then graph out that ping response time over time. So in this case, it sends multiple ping packets to the target host every 5 minutes. The response time for each of these is graphed out. The distribution gives us an idea of the variation in these ping times. So let's take a look at smoke ping. So if I come in here and I take a look at smoke ping, it shows me that I've got some information from my local machine, but if I go to internet, this shows me each of the different sites that I've been monitoring. So for example, Comcast. Okay. So I was in a meeting some time ago and somebody said, well, I don't trust Comcast because I get 50% packet loss. I said, what thing are you basing that on? And they said, well, it just feels that way. Well, I have to be able to come up with numbers when I say things like that. So in this case, here is the last 3 hours of monitoring Comcast. And I find out that my median round trip time is 13.8 milliseconds to my head-end connection. And I see that my packet loss is about 0.2%. As I come down, I can take a look at the last 30 hours. I could take a look at the last 10 days. So my packet loss for the last 10 days is 0.07%. That's a lot less than 50. And if I look at the last year, we can see that this particular device at Comcast stopped responding for a while, so that throws off my numbers a little bit. But if we were to zoom in, and I were to say, before that happened, what did my numbers look like? 0.16%. That's acceptable. If I see less than 0.5%, I'm happy. My buddy Doug, I can say, I've got it set up monitoring connectivity to his house. We can see, what does connectivity look like to Doug's house. And what's interesting is when we look at things like this right here, and we see that we lost connectivity for a little bit, then all of a sudden the latency went up. So this is where I would want to do a path analysis before and after. What changed? Why did we all of a sudden start taking longer to get to Doug's house? And this is where, here's Uta's office. I can monitor that. We see that, every once in a while we'll see a spike in there. Now, if those spikes happen in the middle of the night, this could be backups running. But the key using smoke ping is monitoring that latency and packet loss. So if people say the network is slow, we have a good idea of why is it slow? Well, it's slow because our latency went up. Why did our latency go up? Well, if we go back and we look at the utilization, if we see utilization went up, then that starts giving us an idea of what's going on. Now, if utilization goes up, that's where we need to start looking at things like packet captures, net flow, conversations, types of traffic going across the network. Why has this gone up? And that could be a result of somebody doing a big file transfer across the network. Okay. Without these numbers, it's very, very, very hard to tell what's going on. So smoke ping, great tool for doing that. Now it turns out that we can set up different types of probes. In this case, I'm monitoring DNS latency. So here I'm looking at the latency for a number of different DNS servers. So this tells me Comcast DNS server, about 17.8 milliseconds response time. Google, 17.1. OpenDNS, 17.0. Verizon, 17.5. So they're all pretty even right in there. Another interesting one is where we take, and I can look at HTTP latency. So here I'm looking at HTTP latency for Google. Now, in this case, we see that when we started doing our webcast, we see that that latency went up a little bit. I can even stack these. And this is looking at ping response time with HTTP response time. So this gives me an idea, is this a server issue? Is this a network round trip time problem? Now this could be a result of contention for download, but we do see, coincidentally, that the response time here went up about the same time that we started doing this webcast. Okay. Smoke ping, great tool. Let's kind of flip through there. All right, so again, if you have questions, comments, please don't hesitate to use the live chat there, send those in. More than happy to address those as we're going along. OpenNMS. So when it comes to monitoring our network, we want to be able to find out what's up and what's down. And OpenNMS is one of those tools that we can use for doing that. So OpenNMS allows us to measure device availability, get notification of problems. So I can set this up so if a device stops responding, it will send me an email, OpenNMS will, let me know that device is down. If that device comes back up again, OpenNMS will send me an email and let me know that it's been resolved. So I can get availability reports out of here, and we find that it is a highly scalable tool. So let's go ahead. We've got OpenNMS set up. So let's just flip over, and we are going to bring up OpenNMS. So here's OpenNMS on my system. So it shows me, what network interfaces are up or down. Shows me status of web servers. It shows me my DNS, DHCP servers, etc. So what we can do is, we can come in and see what nodes we're monitoring. I can see what services on each node that I'm monitoring, the interfaces, etc. Let me just show you real quick. Once we get OpenNMS set up, and once we set it out there and have it discover our network, I could come out here and I could go to reports. I could say I want to do database reports. I'm going to list out the reports I have available. Now in this case, what I'm interested in is availability by node. So I'm going to run that report. So this is going to do a report on my routers. And we could set the time range. I'm going to say 30 days. And I'm going to say I want to get that from the 1st of June. So let me know, how did things look for June? Because if somebody said, look, the network is going down all the time, I want to know if the network is going down all the time. So I'm going to hit run report. So OpenNMS is going to go out, it's going to look at that database of information, and it's going to tell me that over that 30-day period, my MikroTik router here in Maple Valley, where I'm at, did not go down once. It was 100% available. And we can see that the Milton MikroTik, that's Uta's office, over the VPN tunnel, went down 5 times with a mean time to repair of 0.1 hours. Total outage was 1/2 hour. And if we look at the percentage, that was 0.07%. That kind of ties in pretty good with some of those other numbers we saw for Comcast. So it tells us that her office was available 99.93% of the time. That's pretty good. Can't complain about that. So it gives us overall numbers. So what we find is this helps us either implicate or exonerate our network. It helps us know whether we are seeing outages, and if we are, where are those outages occurring? And the nice thing is, once we set this up, it just sits here and runs, and runs, and runs, and runs, and runs. So unfortunately, I don't have time to go through how to totally set up OpenNMS. One of the big things out of this presentation that I wanted to get is introduce you to what some of these tools are. What can we do as far as instrumenting our network? And if you don't want to go out and spend a huge sum of money, there are tools out there. Now, what's the trade-off? The trade-off is that many of these tools may require more configuration than some tools that you spend a lot of money on. You can also find that these tools don't all integrate tightly together. So OpenNMS isn't integrating with Smoke. Well, I hate to say it isn't integrating with SmokePing, because what we find is that some of the tools that we see with SmokePing are included in here. So if I came in and I said, I'm interested in the Uta Office node, and I say I want to see response time for her router. Well, this is actually coming in and it's monitoring that response time. So we do see that there is a little bit of overlap here, in that we are not only monitoring availability, but we are monitoring response time on Uta's office. So we can see, what does our HTTP response time look like? What does our ICMP response time look like over time? Now the great thing is that if I came in and I get my surveillance category set up properly, I could come in and I could see, are things up? So for my environmental, it says 1 of 4. So, I've got some devices out there that I used to have connected up that aren't being monitored anymore. But this gives me a way that if I have this up and I see that everything is green, that tells me everything's good. If I see red, that tells me that there's a problem and I need to start drilling in and seeing what's going on. So red light, green light monitoring, OpenNMS, great tool. So I can come in here, I can monitor individual services. So not only with OpenNMS can I do pings, but I can take a look at things like what my SNMP response, or I can see, is SNMP up, is HTTP up? So sometimes we end up in a situation where one of these, one of these services right over here goes down. not the whole server. So if all I'm doing is pinging the server, it'll tell me the server's up. But really what I want to know is one of these services down? And if it is down, then I need to figure out how to get in there and get that service back up again. So this is where we can go in and take a look at our outages over time and see, is this a habitual problem? Now, the other thing that's cool with this whole idea of putting network monitoring out at the remote site, I could run OpenNMS on my network monitoring platform out at my remote location. So now not only am I looking from the data center out to the remote site, but I'm looking from the remote site back to the data center and to cloud-based services. Because as we move to the cloud, one of the things we run into is that those devices out at those remote locations may be accessing those cloud services directly, and they're never going through our data center. So we lose that visibility. So by putting that monitoring out there at the remote location, we get some of that visibility back. curl. I use this for measuring HTTP response time. Now there's all kinds of fun things that we can do with this, but in this case we're going to take a look at how we can use it to measure. So it is used to transfer data to and from a server. So if I just want to download a file, I could use this utility to do that. But in this case we're going to use it to measure website response time. So what we do is we start by creating a file in here, and I called it curl-format.txt. And we say time name lookup, and there's a variable called time name lookup, time connect, app connect, pre-transfer, redirect, start of transfer. So what this will do is it's going to go out, it's going to do a DNS lookup, it's going to do a TCP connection, it is going to connect to the server, send an HTTP get a response back, it's going to give us some response times. This is the command we're going to use. So, that being said, let's see if we can get a So, here's Uta's Raspberry Pi. So I'm going to go and say CD, and I'm going to list that out. So what we find is if we list this out, there's that file that I just told you about. So I went in and created that. So now I'm going to type in that command I just showed you. So I'm going to run that on my website. So this comes back and it tells me it took 1.377 seconds to bring my website up. Ouch! That's slow. Now, it took 41 milliseconds to look my website up from DNS. So if I thought DNS was the problem, this would give me an idea. Now, one thing that's important to note, these times are additive. So if I wanted to figure out what my TCP connect time was, I would subtract 41 milliseconds from the 100. So that would tell me it took about 59 milliseconds to establish the TCP connection. That is my TCP round trip time for this network connection. So is this a slow network? Probably not. Now as we come down here, we see that our pre-transfer, okay, that's just going to be a millisecond. Our start of transfer, in this case, our start of transfer was 1.294 seconds. That is the time from when we send our HTTP GET to when we get the first byte of data back. Well, that's bad. That tells us we have a slow web server. Now, I can tell you, I pay $6 a month for this web service. I expect a very fast, it's what you get, right? You're on a shared server. We find that if we're not paying a lot for it, we're probably not getting a lot of CPU out there. So we can use this as a way to look at what our response time is. So if I hit up arrow and I change this to interop, so interop, my name lookup. Now in this case, what took me a lot of time was my name lookup at 1.2 seconds. Now I'm going to run it again, and this time our name lookup is a lot faster. So we could go out and we could test a variety of different websites and find out what does the response time look like for that. Let's try Costco. Okay. Now in that case, our DNS lookups are pretty slow. But now once we get our DNS lookup going, see how when we run it the second time it's so much faster because now we've cached that DNS. So in this case, for UTAs, I would want to find out what DNS server are we using and why is that DNS so slow to respond? It's kind of an interesting one there. So this gives us an idea of what each one of our time values are. Now, Elasticsearch. This is another one where we could probably spend days going through what we can do with Elasticsearch. But the idea with Elasticsearch, and let me see what I've got in here, is we have one server set up that is running Logstash. So the Logstash process is listening for packets coming in on port 514 UDP. This is a standard syslog port. So I've set up all of my devices so that they are sending their syslog information to the IP address of the device running Logstash. Logstash collects this information and it parses it apart. So there are a number of grok rules on the Logstash server that parse these syslog messages apart and put the data that's in those syslog messages into specific fields. Now, after it takes and parses those log messages apart, it takes that information and it stores it in Elasticsearch. Now, Elasticsearch is the database backend that allows us to store this information. We're going to go through and take a look at these different screens and what we can do with Elasticsearch. Kibana is the GUI front end that allows us to query the Elasticsearch information and bring that information in and display it in a useful manner. So there are a vast number of very good tutorials out there on how to set up ELK, the Elasticsearch, Logstash, and Kibana, as far as being able to go in and monitor this. So I'm not going to spend time on how we go in and set this up. I am going to spend some time on how we can use this to view the information that's been collected. So in this case, Logstash and grok. So what I've got is I've got all of these rules set up on my Logstash server. So as a message comes in, it is looking for certain patterns. I'm going to grab this chair here for a second. It is looking for certain patterns in that data, and based on that data, it's going to parse that information apart. And it will take that information and then write that into Logstash. Okay? So now we've collected this information from all of my routers and switches and devices that are sending that in. And here, I'll tell you what, I'm just going to do this now that I'm sitting down. Let me just move me a little bit here. There we go. All right. So Elasticsearch, once we get this information stored in Elasticsearch, we can now start going in and running queries on it. So let's do this. Let's take and switch over here to our web browser. Minimize that. And we're going to come in, and here's Kibana, and this is going out and it's querying our database. Now in this case I'm looking at this packet index. Now this is one that it's way beyond what we would cover in here, but it turns out that we can output data from Wireshark in XML format, and we can bring this into Elasticsearch. We're going to click on Logstash. What this is doing is this is going to look at the last 15 minutes of information that we've collected. Okay. So if I came down here and we saw that, we've got information coming from my MikroTik router, I can expand this record. And it's going to tell me this is all of the information that was stored in here. It tells me when it occurred. So we can take a look at what time that message came through. We can see where it was received from, the source host. So this starts giving us some information about what's going on in this particular log message. Now this is great stuff. I mean, I can go in and I can start getting do searches. So I could say, you know what, I want to look for blocked. And I'll hit enter. Now when I search for blocked, what this will do is this will apply a filter to all of the information that I've collected in the last 15 minutes. And it'll tell me I got 258 hits. And it says blocked input. And it tells me, what was blocked. So I can start getting an idea of, do I see that, destination port 1695. So in this case, let's expand this. This tells me that we had a device come in, 50.194.62.34, which is one of mine, and it was trying to get to port 1695, and we blocked that traffic. So this gives us the ability to come in and see what traffic was blocked. Now, this is great, but it takes a long time to dig through all that information. So what we can do is we can come over here to Visualize. Visualize allows us to come in and start creating visualizations of that data. So in this case, I want to create a blocked port graph. So we'll click on that. So what I've done is I've taken that data that I collected and I said, create a graph showing me which ports are being blocked. And one of the options we have is make it a donut. We could make it a pie, but the donut looks cooler. So this starts showing me which ports are being blocked. So right now I see that port 43611 is a port that we're blocking a lot of traffic for. We had 106 attempts on that port. So if I click on that port, I can now create a filter on just that port. I can delete that filter. So after I create the visualizations, what I do is I combine those visualizations into a dashboard. This is a dashboard I created of all of the blocked ports in the last 15 minutes. So what this does is this shows me, and I set it up so it does GeoIP lookups. So what this will do is this will come in and show me what country is trying to get into my network. It shows me what port is being attacked. So, and it shows me the actual attacks down here and where those attacks originated and what ports they're trying to get into. Now we saw that we had port 43166. So if I click on that port right there, it now creates a filter on that. So all of the data I'm going to see is filtered down on that. So we can see that most of those attacks are coming from Germany. We see some from Russia, Japan, Canada, France, India, Israel. Over here on our map, we can start zooming in and start seeing the cities where those attacks are originating. So in this case, we saw that there were a number of attacks from Germany. So we could go in and start finding out, where in Germany. So let's click on Germany. So now it creates a filter, not only on that port, but it's creating it on Germany. So I could start getting an idea of where in Germany is this attack coming from. And depending on the accuracy of our map, now that's as far as I can drill in. But this starts giving me a picture of where is that attack coming from there in Germany. I can remove these filters. I could say, I'm going to hit delete on that filter. I'm going to see what other ports am I being attacked on from Germany. Is this just one particular port, or is this a number of ports? Now in this case, it looks like it's just that one port. So now we'll remove the Germany filter. We'll take a look and see what's going on. So what this allows us to do is go in and start monitoring and graphing out that information. Now if I came in and I said destination NAT, well, what I did was I set up another visualization that said what ports am I allowing through. Now port 5002 is one that I use for doing some monitoring. So I know that I expect to see port 5002. But I could say for the last 24 hours, what ports have I allowed connectivity on? Well, I've got port 565, traffic's come in on that, and I've got port 5002. So here I was giving people a hard time about giving information about what their network configuration is. I guess I'm showing you what ports I have, some of the ports I have open. But in this case, what this is doing is giving us a picture of what traffic are we allowing into our network. And by getting an idea of what traffic we allow into our network, we can ensure that our firewall rules are set up properly. Okay. So, Elasticsearch. Elasticsearch is one of these tools that allows us to collect a phenomenal amount of information. As an example, I mentioned PacketBeat. PacketBeat, what it does is it collects information about the packet. So for instance, this is going out and showing me what my website response time is. Now in this case, these are websites that I'm monitoring right now. But this is coming back and telling me what's my HTTP response code. So PacketBeat is a part of the ELK setup that we can load on a device. It will collect information about the packets that are going across the wire. So it's listening to the interface. It's collecting information from that Ethernet tap, and it's displaying that information out there. So it's going to collect that. It's going to give us an idea of what do our response times look like. One of the things that's really neat that I discovered with, this is the older version of Kibana. This is the latest version. We can do some pretty cool things in here. If I said that I wanted to create a new visualization, I could say I want to add a visualization. One of the new ones in here is a heat map. And this is where I could come in and I could say, you know, from logstash, you know, what value do I want to take a look at? I could say average, and we could say, ooh, well, let's see. Well, it's looking for numbers there. Oh, let's do a count. Yeah, see, this is where, you know, we can start coming through and looking for particular numbers. We could say, oh, destination port. And we could say, you know, we want to do a date histogram. And I'm just, this is one of those, you know, live things that we could do that can cause all kinds of challenges. But, you know, this could show us, you know, how many unique ports are being attacked. Well, let's just do a count. And we're going to say up here, we're going to say blocked. So this starts giving us an idea of how many times that's being blocked. And let's see if we can add a sub bucket here. And we're going to say term. And let's say see what that gives us. What I'm looking for is to show by routers I'm monitoring. Okay, so in this case, what this is doing, kind of got lucky here, this is showing me the number of attacks by IP address here. So for each of my different routers, which router is getting attacked the most. So in this case, I can see that down here, on this particular router, very few attempts to get in, very few blocked packets. On this particular router, a few more. And up here on this router, this is my main router, quite a few more. So I could see, you know, am I seeing more attacks on one router than the other? So I could go in, set up that visualization. I could now save this. I could call it blocked ports heat map, and I'll hit save. I could come into my dashboard, and I could say that I want to edit my dashboard. I want to add, and I'll find blocked port heat map. Don't want to add a new visualization. And I'll hit save. So now I've just added that heat map down here to that particular screen. So this is where, you know, once you get data that starts rolling in here into Elasticsearch, you can start graphing that out to your heart's content. You can find out, you know, which of the routers are being attacked the most. I could see, you know, if I set a filter on a particular location, I can get an idea of what's going on in there with that data. All right, so that was my destination NAT. I could go back and set that to my blocked ports. All right. So here's an example of where we put together a dashboard in there. So, a lot of information, a lot of stuff to cover. I'll move over a little bit so you can see my email address. Actually, let me just make myself a little bit smaller here. Not taking up all that space. Will move me over there. That's kind of handy. All right. So for those of you that have hung on for this entire time, I'd like to thank you. And I hope that you found the information that I talked about today useful. And if you were part of the group that wasn't able to get into the room at Interop, I'm sorry. Hopefully we'll have more room next time, get everyone in there. But these are some of the tools that we covered in that presentation. There are thousands of very good free network troubleshooting tools available. And a lot of times, and this is what I've had to do, I've sat down and said, this is what I want to accomplish. This is what I want to be able to monitor, and start going out and taking a look at tools. So, this is recorded, so you can go back, you can take a look at this after we've saved it. Like I said, if you want to shoot me an email, I'd be more than happy to send you the PDF that goes along with this. Yeah, so one of the questions, can I get a copy of this? Absolutely. My email is out there. You got my email right here on this screen, right there. Shoot me an email, and I will send you a PDF with this information in it. It's got the different commands and so on. Because my goal is to help you be as successful as you can with going out and doing network troubleshooting. And so that's why we're doing things like this. And I'd like to thank Susan with Network Computing Magazine and UBM. She helped me get this set up, or she was the one that instigated this. They did a really nice little article on the tools about what I did and promoted this. So hopefully, if this is something that you found useful, that we'll try and get more of these out there. So I enjoy doing it. I can do it right here from this little studio I set up, and we can get that info out there. I want to thank everyone that submitted questions and so on. You've got my email address. If you have any questions later on, please don't hesitate to shoot me an email. I'll do my best to get a response back to you. All right, so that's about it for the presentation. I want to thank everyone for joining on, and hopefully we'll see you in another one of these. And if nothing else, there's my email address. Let me know what you think, if this was a good format, what worked, what didn't. This is really our first YouTube Live that we've done. Any information that I can get back as far as feedback goes, that's always great. All right, well, thank you very much. And if there's no other comments, we're going to go ahead and shut down the stream here. So I'll just hang out for a minute and see if anything else comes in. All right, well, I'm going to go ahead and sign off. Thank you very much for joining, and hopefully see you on one in the future.